0. So you have your x and your approximate y value. So that's the table we're going to make right here. So if we do x and our approximate y value, our first y value is actually known. We know when x is 0, y is what? 0. So what's that third column we like to do? Delta y, right? And delta y was going to be equal to what? Slope times what? Delta x, exactly. So if we start filling these things in here, zoom in a little bit, it's x cubed minus y cubed, so in this case the slope is 0, right? And we multiply by delta x, which is 1/5. So what's the change in y going to be? 0. What's the next x value? What's the next x value? What? 0 point what? 0.2, because it's 1/5. And what do we add to the last y value? What do we add? We add. So we're still at 0. Okay, that's nice. We're not stuck there. You might think, hey, we're going to be stuck there. We're not. So now when we cube this, what's our next slope going to be? It's going to be x cubed minus y cubed. So that's going to be 1/5 what? Or I'll use decimals if you want to. That's going to be, yeah, I can do 1/5. It's like 1/5 cubed, right? Times, what's delta x? What's delta x? It is not changing. 1/5. So in this case, we know that delta y is going to be 1/5 to the what power? 1/5 to the 4th. So what's our next x value? 0.4. And what are we adding to 0, which is our last y value? We're adding 1/5 to the 4th. So we have 1/5 to the 4th. You there with me so far? At this point, what do you start needing to use? Probably. You're probably going to need to start using your calculator at this point. Are you okay with this method so far? Are you okay with this method so far? If you keep on doing this, and again, is the AP exam you're going to do 0.6, then 0.8, and then you're going to get to 1.0? Anybody have the estimate for y? Did anybody go that far? Integrate this. Basically find the solution to this differential with a constant, right? Find the solution to this differential. What's that first step you have to do? Separation of variables. So you end up with dB over 0.05b, right, equals dt. Now what can you do after you've separated variables? Integrate, right? You can integrate this thing. So what does this become? 1 over 0.05 times what? ln of what? Oh, can I am I allowed to factor that out? Yeah, I can factor that out, right? ln of what? Absolute value of b. Is that correct? Equals t plus some constant, right? Interesting. Should I have, okay, so if I wanted to now, what should I now solve for? I want to solve for b. If I want to solve for b, what do I have to do first? Yeah, or just multiply both sides by, you could do 0. Why do I have to do that before like, what's the point? Why do I have to do that? Why can't I just do e to the power? Yeah, so you can isolate. So you have e to the 0.05 times t plus c1 equals what? And you can just do positive b because e to a power is always going to be positive. So what do you end up with here? You end up with b is equal to e to the 0.05 t, e to the 0.05 c1, right? What are we going to, we did this before. What are we going to call this? Yeah, call it c2. So you end up with b in terms of t is equal to c2 times e to the 0.05 t. Have you seen a formula like that before? Yeah, you've seen this. A equals p times e to the RT, right? That's the formula for what? Continuous interest, right? Right? Okay, yep. A equals p times e to the RT. So you have continuous interest. So this is continuous interest. Kind of makes sense. You need an initial condition. You need to know what C2 is. There it is. So if you break this up infinitely, which is what you would do, is if you did an infinite division for Euler's method, meaning you took delta x to be infinitely small, what do you get? You get the exact solution curve. There's your connection. For A, who can tell me the answer for A? And circle? Yeah, what's the circle? X equals 2 goes infinite. Well, hold on. The circle is, hold on. No. The circle, radius 2, centered at the origin, is just r equals 2. That's one of the glories of using polar coordinates is we get circles real easy. Now equation for a line at x equals 1, you know that x is equal to r cosine theta, so what do you substitute in for what? So you know 1 is equal to r cosine theta, but you want this in terms, you want to isolate which variable? So r is equal to 1 over cosine theta. So you now have your 2 equations that you need right there and there. So now you can go about doing B and C. At the circle, so what region are you looking at right there? A little cap, right? You know, my shading is not bad, okay? So this is what we're looking for here. So what's the first thing we need to find? Well, write down the equation. Don't we have an equation of some kind, right? What equation do we have? What's the equation? No. That's the equation for the actual function, but what's the area function for polar land? The area is going to be equal to 1/2 alpha to beta f theta squared d theta. Well, it's the function is r theta. Yeah. So correct. You could say r theta. Correct. Nice. Okay. So what do we need to do? So the radius is not. It's not just one line, right? There's 2 integrals going on here. There's 2 integrals. Remember, you're scanning from here to there. So what do you want to find first? What do you want to do next? There's lots of different things you can do. Fiona, what? The little pi up there. No. What'd you say? Find the intersection. You need to find alpha and beta. So find the intersections. Exactly, right. So you know that you're trying to solve 2 is equal to what? 1 over cosine theta. So cosine theta is equal to, so we're looking for the inverse cosine. What does that equal? The cosine of what is 1/2? Pi over 3. Pi over 3, exactly. So in this case, we now know our integral is going to be 1/2 the integral of what? And hey, is there any symmetry involved in here? So what could we do instead? 2 times this from 0 to what? Pi over 3, and we need to know, we have to do this twice. So there's an inner radius and an outer radius, right? And you have to square them each individually. You're basically finding this whole area, and what are you subtracting? This area. Hold on a sec. Let's do this, and then you can have other methods, okay? So what are we going to do? Integral from 0 to this, yep. 2 what? 2 squared d theta, right? We have to break this into 2 integrals, 0 to pi over 3. That's the outer one, right? The circle has a radius of 2 the entire time. What's the equation for the inner one? 1 over cosine theta squared d theta. Yeah, there it is, right there. Absolutely. Fantastic. Could you evaluate those integrals? Is there a short? What's the first thing you have to do on this one? Yeah. So what? No, not substitute. The first thing you always do is rewrite it as a limit. Just rewrite it as a limit right now. Rewrite it as a limit right now. So the limit as b goes to infinity of 3 to b of dx over x ln x. Now it's not technically incorrect to do something else first, but now you need to integrate that. But to integrate that, what method you're going to need to use? Substitution. U is going to be ln x. So what's du? Dx. So what does dx equal? Du. So let's do the substitution now. Limit as b goes to infinity. 3 to what? 3 to b. You're absolutely correct. Because you're doing the substitution. Yep. You're doing the substitution. Correct. ln 3. So then you have dx, but instead of dx you have x du all over x u what? What's the magical thing that happens now that you love? The x's go away. Is that a magical thing that really, really helps you? Say yes, it is, because if you don't, you can't go any further. So we end up with the limit as b goes to infinity, ln 3 to b of 1 over u squared du. What's another way to write that? U to the negative 2. So that's going to be the limit as b goes to infinity, ln3 to b. But if we do the integration, what do we end up with? Negative 1 u from to b. Is that good? We're doing okay so far? Okay. So the limit as b goes to infinity of negative 1 over b minus what? Negative 1 over ln3. What does this first one go to? 0. Nice. It goes to 0. So what do you end up with? 1 over ln3. Absolutely. Yay. Okay. So what I'd like you to do